Okay, so in capacitance, we are going to be discussing um, the first thing as the basic or the simple concepts of the capacitance. Okay, okay, basics of capacitance. Okay, and then we have to discuss the capacitor in series and parallel, capacitors in series and parallel, and then we have to discuss the charging and discharging of capacitors. Okay. And by the way, this last topic is newly added in the syllabus and from 2020 onward till present. Okay. And by the way, please keep in mind that the chapter is going to be slightly easy. Okay. But after adding the last content, it is like quite difficult, but not that much. Okay. And in the paper, you will going to expect 6 to 8 mark question. Okay, in P4, in P4. Okay, and it is more related or more similar to the chapter you studied in your AS electricity, right? It is like similar to that, right? So now let's let's begin. So, okay, by the way, this is how the capacitor looks like mainly in the circuit, right? So if you dismantle any toys, okay, that contain the electric circuit, right? Mainly the PCB, the printed circuit board looks like greenish, okay, and onto that a lot of component are soldered onto it, right? So these are one of the type of the capacitor that you can see in that PCB or in anywhere in the circuits, right? So this is how the circuits look like, the capacitor look like, okay? And the other thing is this is basically used in many circuit that contain or that require charging or discharging, right? Or energy storage, right? So its main purpose is that, okay? So is energy storing. Okay, so basically, if we try to draw the schematic diagram for the capacitor, like how you can draw it on the paper or on the screen on your answer sheet. So this is how it should look like. Okay, so one of the terminal is going to be positive, okay, and the other terminal is going to be negative, right? And you will have a wire or you will have a leg, okay, like this. Okay, so this is how it looks like, okay? And there should be something in between, or let me just make it like this. Perfect. Wait. Come on, people. Good. Okay, so and sometime it is also drawn like that with one side straight, okay? And the other side slightly curved. Actually, the black side should be straight, okay? We don't need to remember it, okay? Because it is not a part of your syllabus, okay? And this is how it looks like, right? And this
Is
is also
this?
what it looks
What
like.
is this?
It is basically the capacitor. Both are the capacitor, right? Like this is how you can draw it in the circuit, right? So like previously where you have the resistor, so you used to draw it like that, right? So similarly for the capacitor, you have to draw it like that. Not like this, but mainly capacitors are being referred with this symbol. But actually in our syllabus, we're going to refer this the first one, okay? And over here, it is called the parallel plate capacitor. With this being, wait, come on. With this being the metal plates, okay, okay, metal plates should be greater than that. Metal plates, okay, they are parallel metal plates, okay. And the second thing is that this is the medium, okay. This is the medium in between the plate, okay. By the way, the plates are not connected in by anything, okay. They're just the medium, okay. And these are the leg, okay. These are the terminals, okay. So this is the terminal, and terminal, okay. By the way, the capacitor is like, unlike the resistor, capacitor has the positive and negative terminal, okay. And since it is the energy storing component, so it should have a positive and a negative terminal, okay. So by the way, again, not required in our syllabus, like to remember the positive terminal or the negative terminal, okay. We don't want that, okay. But in reality, you should have, or you should know that um there are two terminals, the positive and the negative terminal, and you have to connect in the circuit with the correct polarity, okay. The positive terminal of the capacitor should be connected with the positive terminal of the battery, and so as with the negative terminal, okay. Now, okay, so moving on to the concept or definition of the capacitance, okay. So the basic definition of the capacitance is the ratio. It is the ratio, okay, ratio of charge stored per unit potential difference, okay. Potential difference, okay. Now, if we write the formula for the capacitance using the definition, so it will going to be C is equals to Q over V, right? Make sense? Now,
Yeah.
you can we usually relate this formula with Q is equals to CV, by the way, but you can use any if you want, right? Q is equals to CV. This is the more like, this is a general relationship that everybody referred, okay. So yeah. Now, if I ask you about the units, so what will you tell me? And the base unit and the drive unit, both.
This one is
Mm-hmm.
Farad, yeah? Or
Felt, okay. But it is not any unit. It's the name of the scientist, by the way. Like Michael Faraday was a scientist in 18th, I think 19th century. and you worked a lot in different physics field, right? Mainly in old physics and in the new physics, right? The quantum field. So that's why we use his name for various scenarios, but not actually the unit for the capacitance, right? You can use the formula to for the unit, right? So just you can look at the formula and you can tell me the unit by looking at the formula. Ibrahim, it is you who joined the meeting right now?
Yes, sir.
Okay, bro. Okay. Any idea? Anyone can guess the base unit or drive unit from the formula for the
uh,
capacitance?
coulomb per unit
Oh,
volt.
very good. Very good. Correct. Okay. So it is Coulomb per volt. Okay. Very good. Right. And its corresponding base unit is going to be you can drive it, right? So you know that Coulomb is basically AS, right? And voltage is basically energy over charge. So energy is kg meter second negative 2, right? Overcharge is going to be AS. Okay, this is the unit for the volts. Okay, and you can just simplify it, so you'll get kg meters second negative 2. That's just sorry, it should be positive. The first one is positive and the second one is negative, right? So as negative 3 is become negative 3 and a negative 1. Okay, and then when you substitute that back in the formula, so you will get AS positive. Okay, AS positive, and the rest of the thing, the voltage should be in the denominator, so it should all be in the negative. So kg negative 1, meter negative 2, s positive 3, and a positive 1. Okay, so this positive a and positive a become positive 2a, positive a to the second power. Okay, and s become s to the fourth power, and kg become kg negative 1, and meter become meter negative 2, right? So this is the base unit and that is the drive unit, right? By the way, in the memory of that scientist called Michael Faraday, we replace the unit of the capacitor from volts per coulomb to Faraday, okay, to farad, right? So now it is known as farad. Okay, so this is basically, this is not a unit. Farad is not a unit. It is for the sake of remembrance of that scientist, right? We have given the name to that quantity, right? As like the Newton for the force, right? Similarly, the watt for the power, the Pascal for the pressure, the hertz for the frequency, all are the name of the scientist. Okay, they aren't the actual unit for that quantity. Fine. And also the capacitance is is a scalar quantity. Okay. Scalar quantity. We don't have any direction in it. Okay. Quantity. It is just going to tell you the amount of how much something can store the amount of charges, right? Now, so if we talk about the farad actually, so farad is basically the unit for the capacitance, okay? The drive unit, or actually the unit for the capacitance, right? Now, if if we try to explain the farad, okay, like the way we used to do the ohms in AS level, the volts in AS level, right? Similarly, for the farad, we can say that it is the ratio of coulomb coulomb per volt. Okay, per volts. Don't write voltage. Okay, voltage is a quantity, right? We have to define unit in terms of unit. Okay. Now, this is the basic sense of the capacitance. Okay, and the capacitance is like the general concept. Anything that can store the charge can have a capacitance, right? Or will have a capacitance, or should have a capacitance, right? But in a specific, we have a parallel plate. We have a lot of different type of capacitors, out of which we will going to discuss a parallel plate capacitor. Okay, so over here we should also know the definition of the parallel plate capacitor as well. Okay, so this is the capacitance of the parallel plate capacitor. Okay, by the way, for the first definition, they'll ask you in 1 mark or 2 mark, in 1 mark maximum. Okay, for the capacitance. Okay, but as far as the second capacitance, second definition is concerned, okay, they'll ask you in like 2 mark at least or 3 mark. Okay, so we used to write it as it is a ratio ratio of charge store on any one plate per unit potential difference across the plate. Okay, so this is the definition for the capacitors, okay, of the parallel plate capacitor, okay. Right, be careful, right? You have to write the whole thing in 1 mark, in 2 mark, okay. If they ask you for the about the parallel plate capacitor, right? Now, if we try to understand, by the way, in this chapter, we're going to discuss two type of charges, okay. The two type of capacitance. Basically, the first one is going to be um this one, okay, the spherical capacitor, okay. Let me just write the spherical capacitor, okay, and the spherical capacitor, okay, and it can store a positive charge or it can store a negative charge. Or let me just make a positive one for you. Ooh, yeah, yeah, okay, and color intensity fed up, and if I just make it 2 and I can rotate, oh man, can I? Nope. Okay, let me just make another. Okay, and should be greater than that. Okay, and let's just put it right here. Ooh, good. Left line looking good. Mm, in the center, yes. Okay, so we can have it a little bit small and make it as many as we want and just store it. There's not any emoji. It's a positive charge that I'm storing. Okay, so this is how it should look like. Okay, this is how the capacitor should look like. Okay. Okay, like this. Okay, so this is the first concept, and that is a charge store on any one plate. Okay, that is a spherical capacitor, and the other type of the thing is that is a parallel plate capacitor, and the parallel plate capacitor, uh, according to three dimension, looks like this. Mhm. Okay, come on. Another one right here. Okay, and I want color. ये रिकलर नहीं कर रहा. By the way, this is how it should look like. The parallel plate capacitor. Wait. A bit larger. Yes. Okay. And you have two arms. Okay. One in this direction and one. Okay. So this is how it should look like. Okay. थोड़ा सा बड़ा हो गया. Perfect. So yes. So this is the second parallel plate capacitor, and the first one is a spherical capacitor. Okay. So the spherical capacitor only contain the derivation, the parallel plate capacitor contain the derivation as well as the whole circuit concept. Okay. And I explained both of them. Okay. Now, moving on to the process of charge transfer. Okay. So can anyone, by the way, can anyone explain me how can you transfer the charge? Because like if you look at the circuit, so the circuit is not completed yet. Okay, let me just open the circuit for now. Okay, so initially the circuit is in this stage. Okay, now as I connect this here, okay, so nothing will going to happen, right? Maybe because we have this thing open, right? They're not connected. Okay, in our case the medium will always going to be the medium in our case or in our syllabus will always going to be the vacuum. Okay, so medium will always going to be the vacuum. 35 30. Okay, it is always going to be vacuum. Okay, by the way, now yes, sir. So can anybody explain the process of charge transfer? Like how will we able to store the charge, okay, from the two different plates, okay, if we don't have the connection in between them. If we don't have the connection, we cannot flow the current in between. Okay, so how will we able to achieve this concept, right? So what you can say. By the way, just give me a second, please. I, I'll be back. Just a second, and kindly think on it. Okay, I'll be back. Okay, guys, I'm back. Yes. Can anybody explain, please? How will the charge, um, how will the plate get charged? Anybody? Amna, Ibrahim, and Migdad.
What's up?
How will the capacitor going to store charges? Do you have any idea
Between the
between the
plates?
plates? Yes, yes, yes. No idea. And anyone, anybody else?
No, sir.
No idea. Ibrahim, no idea. Okay. Okay, just try to see. Try to understand. So initially, if we look at the plates, so both plates will have equal amount of positive and negative charge, which we known as the neutral plates. Okay, initially both don't have any charge, right? And as you connect the plates to the battery, okay, and as you close the switch, okay, so what will happen is the positive terminal of the battery, the positive terminal of the battery will going to attract all the negative charges out, okay, and it will take the negative charge through the battery to the opposite, to the other plate, right? And all the charges will get stored onto the next plate, right? And this process of charges continue till all of this energy get utilized, okay? If you provided the capacitor with more energy, then the charging will continue for a longer period of time. But if you have the smaller power supply, then the charging process or scenario will end up soon, right? Is that clear, guys? Let me just write it down. I think it will be more helpful for you. Okay. So I'm saying um sorry. So the positive terminal of the battery battery attracts the electron out from the metal plates, okay? From the metal plates, okay? And they get they get stored on the opposite plate, okay? Now, this will make this will make the first plate first plate positively charged, positively charged, okay, and the other plate negatively charged, okay, negatively charged, negatively charged, right? So this is how the process of charging occur. in the capacitor. Okay, and always remember, once you charge the capacitor, then if you place that capacitor into any circuit, then it will act as a battery in that circuit. Okay, so if the capacitor is fully charged, then it will act as a battery. If the capacitor is fully discharged, then it will act as an energy storing element from the battery. Okay, so this is a concept, right? And this is how the charge stores in the capacitor, right? Now, the point, okay, let me just show you one thing where you'll have a fair idea of how all the things are done. Um, PHET, well, PHET simulation. I want it in the big screen. How can I make it? Okay, right here. Okay, let me show you the capacitance. Okay, okay, you can see it right here. Okay. So I have the parallel plate capacitor connected with a battery. Okay, and I can make the battery positively charged. I can make the battery positively charged or negatively charged. Okay, according to the like according if I can shift if I shift the slider upward, the battery become positive. If I slide it downward, the battery become negative. Right? I have the parallel plates. Okay, and if I start charging, you can see the direction of electron flow and you can see the direction of charging, right? Okay, is that clear? Can you see it? Yes. So basically, you have the parallel plate, the positive terminal become positive, like the battery positive terminal become positive, right? And the negative terminal of the capacitor become negative, right? Because the positive terminal of the battery attract the electron out, okay, from the positive terminal, and it send the electron to the negative terminal, so it become negative, right? So this is the simple concept of the capacitor, right? And if I show you the electric field around in between the metal plates, so this is how the electric field looks like. Okay, and yeah, this is the main concept of the capacitor, right? How it store charges and how it if I just remove the battery, or if I just reduces the charge value or potential value, so it will start decreasing, right? And if I reverse the battery, it will store in the opposite direction, okay, to the maximum, right? Now, if I by the way if I now connected with a bulb, okay. So now the capacitor is disconnected with the battery, right? It will not disconnect until unless you will touch two of its legs together. So it will suddenly discharge. But the other way of discharging the capacitor is you can connect it with any power supply, with any component, okay, that consumes its charge or its energy, right? And providing it a discharge path, right? So if I connect it with a bulb, so it will going to provide you the discharge path, okay, and all of the charge will going to discharge through that bulb, okay, look, and down to zero, right? So we had the maximum charge stored previously, and as we connected that with a bulb, okay, so the bulb consume all of the energy, and it provided the discharge part to the capacitor, and the charge stored on the capacitor start flowing from one plate through the bulb to the other plate and get discharged until it is fully discharged, right? Now you can see any current flowing in it, right? So capacitor does not allow any direct current in the circuit, right? So this is how you can understand the concept of the capacitance, right? And the charge storing. Clear? Now back to the lecture. Okay. So we learned the first concept as the process of a charge transfer. Now we have the second concept, and that is why the capacitor store energy not charge, right? Like as whole, if we talk about the plate, so yes, the plate do store the charges, but if we talk about the whole capacitor, then the whole capacitor is not store charge, it only store energy, right? But how? So you can see that one of the charges from one of the plate is being taken out or are being taken out, and they move to the other plate, right? So if like two of the charges get transported, let's say four of the charges get transported, right? So the red plate or the positive plate become four positively charged, right? And this four electron is stored right here. Okay, this charge will not make any effect because they are in pair and they're neutral. Okay, so that four electron will move right here in this plate, and this will make the blue plate negatively charged, right? And since we are moving the electron from one plate to another plate, we want the energy for the motion or for the movement. So for that, we have to do the work done, and that work done is stored in the form of electric potential energy in the capacitor, right? So for now, we can say that uh, both the plates store equal amount of equal amount of positive and negative charge, right? This is the first concept. Now the second concept is, if we have both the positive and the negative charges in equal amount, then the net charge is going to be zero, right? So the net charge on on the whole capacitor on the whole capacitor will be zero. Be zero, right? This is the second concept. Okay. Now the third concept is, if the net charge is zero on the capacitor, then what does the capacitor store, right? So the capacitor store the energy. Now where the energy is coming from? So the energy is coming from the those charges that get transported from one plate to another plate, right? Energy is coming from these charges, right? We can say that the work the charge transfer required, the work done, okay, which can be stored, which can be stored in the capacitor, which can be stored in the capacitor in the form of electric potential energy. Okay. So this is like frequently asked question. Okay. So this is how you have to answer. Okay. They'll ask you. Sometimes they ask you in the 4 mark. Sometimes they ask you in the 2 mark. Okay. So you have to write accordingly, right? So these are the 4 points you have to write according to the question and according to the marks. Okay. Now, since we talked about that the capacitor is storing energy and not charge, so from this concept we can also identify, we can also write down the uses of the capacitor, right? So, so the main use of the capacitor is to store energy, okay? Store energy, first thing. Come on. Energy, this is the first use, okay? The second use is to use in the smoothing circuit, in the smoothing circuit, okay? Now, don't worry about this smoothing circuit. This will going to be coming in chapter 7, I think, like alternating current. So I'll be explaining the concept of its smoothing and the like the component used for the smoothing. Okay, basically the capacitor is going to be in that circuit, right? But you just need to remember the point for now, okay? Now the third thing is it is used to block DC and allow AC, right? So it block it blocks DC, okay, and allow AC, right? DC is basically direct current sources and AC are the alternating current sources, right? So since the parallel plates are not connected with each other, so that's why once all of the charges or once all of the energy corresponding to the charges get transported to from one plate to another plate, then the current will going to be zero and everything stops, right? So yeah, so the third thing is the it blocks the DC and allow the AC. AC is basically the current that oscillates from one point from around one point, okay, or about a point, okay. So since it is just oscillate back and forth, back and forth, back and forth every time, so it can move or it can flow or it can oscillate in that circuit as well for a period of time, right? Now, the fourth concept is, or the fourth point is, that use in oscillator, and tuning, tuning circuit. Okay. So oscillator circuits are basically a type of circuit in electricity that in which the energy oscillate from one point to another point. You don't have to remember the definition of the oscillator circuit. You don't have to know the any concept. You just need to remember that the capacitor is used in the oscillator circuit and tuning circuit. Okay, this is if you write this point, you will get full mark. Okay, like 1 mark for that. So you'll have to write that down and you'll get the mark. Okay, you don't have to understand what are those circuit, the oscillator circuit and the tuning circuit. By the way, oscillator circuit are the circuit in which the energy oscillates from one form to another form, right? And the tuning circuit is the circuit that catches the frequency of the specific type you want. Like imagine a radio, you want to set a specific frequency corresponding to the radio station that you want to listen. So you just tune your radio to the specific station. Okay, so that tuning is basically possible due to that tuning circuit, okay, that contain the capacitor. Okay, so the capacitor is basically letting the frequencies adjust, okay, and it will show you the your required will yeah, it will show you the your required frequency, right? So these are the four uses. I think fifth point, the fourth point is basically the 2 points. If you write oscillator circuit and turning tuning circuit, not a turning circuit, okay, tuning circuit, okay. So tuning circuit will get 2 mark, okay, because they are the two different points, okay. Now, so that's another uses concept, okay. It is also repeated question. Now, another concept is since we connected the capacitor with the battery and the capacitor is like charging, okay. So for how long will the capacitor keep charging, right? So this is the question. So to answer that question, we have to understand it using circuit diagram. Okay, so imagine I have a capacitor right here, okay, and I am connecting it with a voltmeter, okay. So I have my voltmeter, okay. So this is a voltmeter, right? Now I have another voltmeter. Can I rotate it? Can I rotate it? Please, come on. Okay, so this is the first voltmeter, and that is the second voltmeter. I have connected it right here. Let's bring it to this side. Okay, so the other voltmeter is right here. Okay, and the wires are connected. Okay, now these are the two wires. Okay, so initially, when you connect the battery when you connect the voltmeter across the battery, so initially the voltmeter will going to read 5, and when you connect the voltmeter across the capacitor, it will going to read 0, right? Simple concept, right? But as a charge start storing from one plate to another plate, the potential difference will increases from 0, right? And it will increase from 0 to 1 to 2 to 3 to 4 to 5 until everything gets stopped, okay? Because your potential difference becomes 0, right? So the potential difference at the battery is also 5, and the potential difference at the capacitor is also 5, right? And since the difference between the potential and between these two components is 0, so no electron or no current will get passed through it, right? Because we know that in order for the current to flow in the circuit, there should be the potential difference, okay? And if you kill the potential difference in any way, then you won't have the current flowing, okay? So we can say that okay, so that is, let's say, V1, and this is, let's say, V2, okay? So initially V1 is equals to 5.0, and V2 is 0, okay, initially, right? Then, as the charging started, okay, have the charging started, the potential difference across the across the plate, across the capacitor, increases from 0, okay? This is another concept, right? So since you have connected it from the capacitor, so this voltage value will start increasing, okay? And this remains the same, by the way, right? But the voltage value remains the same, right? It start increases from 0, right? From 0, right? Then, okay, when V2 become equal to 5 volts, okay, then the potential difference between the battery, okay, and the capacitor the capacitor becomes zero, which means over here there's a 5 volt. Okay, over here there is also a 5 volt, right? If we try to find out the potential difference between these 2 points, okay, then we're going to get zero. Okay, you're going to get zero if you have the same volt right here and the same volt right here. Okay, now this is so wait. When the potential difference between the capacitor becomes zero, okay, becomes zero, okay, and flow of charge, come on, flow of charges gets stopped. Right? This is a simple concept, right? That the flow of charge will get stopped, okay, as the charging process continues, right? And when the flow of charges gets stopped, then charge process will ultimately get stopped as well, okay? Come on. Now, that's done. Okay, so this is how the capacitor charges, okay, and the uses of the capacitor and how the capacitor charging ends, right? While the potential difference become between the battery and the voltage becomes zero, right? So this is the concept. This is the main concept or the basic sense of the capacitance we had completed yet. Now I'll move on to the next portion to tomorrow's class, inshallah. Okay, and we'll be discussing some factors affecting the capacitance and the rest of the things. Okay, so okay, fine. So I'm keeping this class till this point. Okay, we'll meet you tomorrow. Till then, take care. Allah Hafiz.
Love is.
Allah Hafiz.